All right, so today we're going to talk about big data and international trade and how Panjiva is creating transparency through information. I'm Peter, this is Keith. So today we're going to talk about the importance of global trade, why this is something you should care about, the promise of trade data, what we can do with it if we can extract valuable information from trade data, the technical challenges that we face in doing this and the solutions we've put into place, the business applications, how it's useful to our clients and parties involved in international trade around the world, and two takeaways that we've got both from the technical side and the business side, lessons we've learned. So the concept of Panjiva is very broadly that global trade is a very important field, and if we can understand it better, there's lots of value to be gained. Global trade touches all countries. So what we see in this figure is we can see the relative size of exporters of different countries as exporters from 2005 to 2013. You'll see that the usual suspects are quite large. China's very large, the US is large, Germany's large. But the more general point is that pretty much every country in the world is exporting. Pretty much every country in the world is involved with international trade. Moreover, global trade's just very, very big. In 2013, it was valued at $18 trillion, and it's grown 9 times since 1980, when it was valued at about $2 trillion. So a map of this network would be extremely useful. So if we could understand this network as a series of companies connected by the links between them, or more generally, entities connected by the business they do together, we would have something very, very valuable. For manufacturers and retailers, we'd be able to tell you basically who makes a given good. You could find different trading partners. You could see what your competitors are doing. For logistics companies, you're able to see what's going in and out of different ports, the individual items going, who's involved in those transactions, who you can call up to get new business for whatever type of vessel you have. You can also just optimize your investment across ports. For governments, you can manage trade, you can encourage trade that you desire, and you can discourage trade that you don't desire, such as illegal or illicit trade, smuggling. In finance, it's obviously very helpful to have a sense of the overall health of economies with as little lag as possible. Additionally, you can look at individual companies. There's commodity trading. There's all sorts of things you can do with this data. So what's the opportunity? The opportunity is that there's very valuable information being generated. There's just tons of it. According to the WTO, the average stack of export documents is 1.5 centimeters thick. So governments are just very, very interested in understanding what's going across their borders. There's generating tons and tons and tons of paperwork. But the flip side of that is that there's tons and tons of paperwork being generated in these very sort of arcane formats and all sorts of forms with all sorts of free text. It's this very similar question to which many of you are dealing with, but it's just data that's not structured very well, but has very, very valuable information therein. Moreover, there's a complex set of privacy laws that can impede acquisition or dissemination of this data. It very much varies by government what you're going to have access to. Some governments are going to be very open. Some governments are going to give you basically nothing. So the challenge is to do this in a way that respects the laws of the governments you're working with, but simultaneously extracts as much value as possible. So at Panjiva, what we're doing is we're mapping this network of trade. We're basically making this network. And we have data from 8 governments. This is customs level, usually transaction level data. So we see the individual transaction going across a border. And we have this data from the US, China, Mexico, Chile, Colombia, Panama, Peru, and Uruguay. Overall, we actually get visibility into 190 countries because some of these governments that we just listed actually provide also the data on the foreign party involved in a transaction. So even if data was not to be available, for example, from France, we can nevertheless see many French companies. This applies around the world. We have about 450 million shipping records, and we have structured 5 million distinct companies based on this data that are involved in international trade. We actually have many more based upon our pulling in data from other sources, such as marketplace websites, things like that. But I think the real meat of the product and what makes this valuable is those profiles of companies that are enriched with trade data, and you can see their position in this network. It's useful to take a look at what the data usually looks like. So here we have an example of US import data. We can see that this is shipments going across the US border. The arrival date is very recently. We can see that there's a shipper field here listed as raw shipper. This is what was listed in the form as it went across the border. You can see it's Samsung in Korea is shipping to Samsung in the US. We have the port that it came in at, Long Beach. We have the item refrigerator, presumably plural. Presumably there were lots of refrigerators in that shipment. Probably. And and you can see also that there's we're just showing 6 of 35 columns in this case. We actually have 35 fields per shipment from the US government. And then for other data sets, such as some of the Latin American data sets, we can actually have hundreds of fields. So there's just tons of valuable information. So what's the technical challenge? The technical challenge is that the raw data is pretty raw. We've got a range of data partners. There's a wide variety of data formats that we're getting the data in. There's a wide variety of regulations and rules about how we can use this data, and it's pretty messy data. There's really if we're lucky, you'll get a tax ID, but usually you won't. Like in the US data, there's no unique identifiers for these companies. There's just these unstructured, there's just these text fields where you have a company name and an address, and you want to make something valuable out of that, but you have like 450 million records. There's a pathological aversion to spell check. I mean, this stuff is being filled out by people who are at the ports, or they may or may not be native English speakers. They just are rushed. I mean, this is not a priority necessarily to fill this out in a clear manner. It's pretty bottom of the barrel. You've got records in multiple languages. If we get records from a Latin American country for government, for example, then we expect them to be in Spanish. The Chinese records, the company names, if we're lucky, we'll get an English name, but otherwise you'll just have the Chinese name and just have the Chinese address in Chinese. So what's the steps? So what we do is, in very broad terms, it's a two-stage process. We get the raw data from the government, whichever government we're dealing with. We receive the data in whatever format's available in, CSV, sometimes PDF, unfortunately, more arcane formats that are just there. We upload the raw data to our database, and we try and preserve its structure as much as possible, or the information therein, before processing it, so that if we ever have to go back to the ground truth, we can then redo everything very easily, and we still have the data available. This is subject to storing it efficiently, of course, some sort of normalization procedure. We also structure the raw text, so there's sort of an intermediate cleaning step where we want to parse that raw text and pull out information that's easily extractable, such as the geographic location of parties. We'd like to structure that information and understand what city is being referenced, what state is being referenced, what region, what country, what's the street address, et cetera. This understanding of the address will allow us to build many things on top of it and also just allow refinement so you can see where all the companies are geolocated. Ports, we simply pull out port information. Units of measure, if that's not pulled out in a separate field from a given government, we'll like to pull that out. It's very interesting to know exactly how much of a given item is being shipped. Then we engage in a more advanced processing. And what we want to do is we want to take this raw data, this transaction level data, and we want to cluster it into profiles of companies, and then we want to understand the links between those profiles. So here's an example of one shipment of petroleum-related goods, I believe it's petroleum-related equipment, that went across the border fairly recently. And we can see that the shipper is coming from Mexico. It's PMI Comercio International. The consignee, who's sort of the direct, more or less the primary recipient, is Atlantic Trading and Marketing in Houston, Texas. But we also have them listed also in the notified parties. Notified parties can be people who are also related to the shipment for whatever reason, finance, logistics, et cetera. And we also have Total Petrochemicals and Refining involved with this shipment. So what we want to do is we want to tag this record to actually our semantic understanding of these 3 companies that are here. Note that one of them is repeated. And we do that through a machine learning-based comparison of sort of the features, the measures of these records, of the addresses and names contained therein. And from that, we can tag this to the right company. We do this through intelligent feature extraction. We thought deeply about similarity of addresses, similarity of names, how to understand where the information is contained in company names across different countries. And then we want to both do this within a given data set, robust to different languages and different ways of writing things, and then we want to match this to other data sets. So, for example, you make clusters of companies based upon the US data. You'd also like to match that to the China data. So then you can see this company from multiple perspectives because you have the foreign party. So what's the technical takeaway? The technical takeaway for me, and one of the important things I've learned from this work is that you really want to generalize from domain expertise. Data science is great, machine learning is great, but you really, really want to understand your data. Why are fields blank? What does it mean? Why are addresses being written this way? What is this field labeled as one thing, but sometimes it contains other things? You want to look at the data and you want to understand it. It's really important. The reason for this is that then you can understand like why you're getting things wrong, but more generally, you want to then push yourself one step further, and you want to research general ways of understanding the domain. What I mean by this is when I look, let's say that I'm trying to understand just matching addresses together. So I've already thought about sort of general pathologies in there, and I could make a great rule-based system maybe about matching together addresses. I'd say if it has this number of shared words, then above 5, which I've just like eyeballed, that's great, then that's going to work and we're going to match them together. That's probably not the way to do it. You probably want to have a more advanced technique that's letting a machine learner set the thresholds, set the function that gives you a measure of, classifies it into a match or not a match. But more generally, let's say that I'm like a real expert. So we've agreed that we're not going to use rule-based methods, but then we want to think intelligently about constructing features. Really use your domain expertise, but don't just let yourself stop and say, okay, I'm a native Mandarin speaker, and so I write addresses from the most general administrative region to the smallest. I start at country, and I go to street. And then I've noticed that in a lot of the other records, it starts at the most specific and goes to the most general. I start at street, and I go to country. That's the normal way for a native English speaker to write an address. So what you want to think about is, okay, so I just flip them and compare them. That could be okay. Now we've got sort of the addresses by a naive measure of string similarity look pretty similar when they are pretty similar. But what if we end up with a third country that writes the city, then the street, then the country? Or just maybe people just like to write things in just arbitrary orders because they're in a hurry. So what I'd really encourage you to do is think more generally, really push yourself about why you can understand an address is similar to another address and why the machine can't. Understand the domain, understand your errors, and then generalize it. Don't stop halfway. I'm now going to hand over to Keith, and he's going to talk about the business.
So I'm going to talk a little bit about the platform and what we do with all of this data that Peter spends every day behind monitors perfecting for us. Basically, one of the things that has been, I think, a common theme in the conference here that I've seen is that people are very interested in the results from big data. They're not necessarily always interested in the raw data, and we've realized that in our customer base as well. So one of our goals at Panjiva is to create actionable data. And kind of going back to what Peter discussed about thinking about the data and what it means very deeply, we know that of all of the use cases, of all of the interesting use cases, there are a couple super classes of use cases that we see most commonly to extract contact information, to find corporate data, whether that's SEC filings, financial reports, product information, trade partners. And what we do is we package all of these kind of super classes of actions into different delivery methods. We have a subscription website. We also have a free website for basic research. We have a CRM tool that we are deploying in the East right now that allows factories to work with buyers in the West without having to hire intermediary parties and track those relationships. We've also developed an API that allows companies that might have sensitive data, proprietary data, to pull the information in to their systems and run analysis in conjunction with their own information without having to divulge it to us. And finally, we do provide custom solutions to people who want us to run their entire analysis. What this looks like at a really broad level is we have a data source that's acquired by our business team. It goes through our pipeline and lands in the database, as Peter just discussed. And then we create kind of an ecosystem of applications that sit on top of that database. And this allows us to do a few things. One, to constantly improve the data on the back end and add more information, restructure it well without interfering with our client's workload. And two, it allows us to deliver very client-specific applications that are extremely simple and streamlined. Since the data itself is so complicated and messy, especially when you start adding in information from other countries, it's a big help to be able to pick the individual action that you want to do and work only on that at one time. So there are a couple of simple business cases here that we see, these super classes that we roll up to. The simplest case is the supply chain case, where we have some intermediary party or a factory or a buyer who wants to find or vet a trading partner. And this is pretty apparent from what Peter was talking about. Basically, you can go onto the system, you can look at this data, and rather than having to pour through what used to be hundreds or thousands, or in some cases hundreds of thousands of documents that are 1.5 centimeters thick each, you simply type in the name of the company you're interested in or some product that they produce and find the location that interests you, and you're presented with what is effectively a graphical overview of all of the information you could want to begin to vet them. And these are what the profiles that Peter mentioned earlier look like. We basically have summary data that allows you to see product images of past production, see all of the shipments from any data source or any government from which we collect the information. We have a separate breakout for Chinese data because it's of such high value. There's a lot of overview statistics there. We extract customer data and supply network data and actually graph it for you in real time and allow you to move through a trade network click by click. We put all of the corporate information into tabs and contact data, as well as allowing you to get directly in contact with people through the platform, whether through VoIP, click to dial, messaging, anything of that nature. And that's a very basic case. The intermediary case that's a little more interesting, adding some abstraction on that, is for logistics and the shipping industry. So the common problem there is that these companies need to figure out how to optimize their shipment flows between ports and trade lanes. And while they have their own information and can clearly see what works for them in the viewpoint of their company, what they're missing and what they've been missing previously was the ability to look at data from other shipping lines, other NVOCCs, other freight forwarders, and then make value-add propositions to customers based on their ability to peel the customers off other people's business and add them to their own trade lanes for less money. So what people will do is they will maybe analyze a port. Let's say I'm interested in the port of LA, which is what I've pulled up in this particular instance. And we can quickly get a sense of where trade is coming from. Clicking into each one of these will actually expand more specific statistics related to it. But this is a great overview. Now if I decide, hey, I want to do business in the port of LA, but I only have maybe $10 million to spend on contracting, on port space, on whatever provisions I need to get to that port, I can actually very quickly, in 2 steps, go through all 60 million, 66 million US import records that we have on the system by clicking 2 buttons, see the top players by TEU, by matching shipments by weight, in some cases by value, in some cases by taxation, by certifications. I can select the individual things that I would need to have, like hazmat permits and things of that nature, and it will automatically just collate that data for you. And beneath this is more information about each individual company. So it's a really interesting case that takes away from having to kind of guess about your competitors' activities to actually knowing what they're doing in your ports. I think the most advanced case goes back to the 3rd and the 4th delivery methods that we briefly talked about, which are API and custom solutions. And that's, in this particular instance, governments generally. Because governments, as Peter said, are very interested in promoting positive trade and making sure that bad things don't come across their borders, which can be very difficult. And one of the difficulties with the data that Peter didn't touch on is that not only do people have a pathological aversion to spelling correctly or spell checking, but people actually specifically game the system. They will actually work in one country to obfuscate what they're shipping to prevent paying tariffs or to prevent being inspected or to prevent having bad food stopped at a port. And they will do that the entire time that the ship is in transit to their benefit. And it's a very common occurrence. So governments, of course, are interested in understanding how are we going to stop these shipments. We can't have a bunch of people at every port looking at every container, but what we can do is compare container descriptions across country borders and understand what one government is inspecting and might not care about and what we do care about, or vice versa. So in this case, we're looking for these anomalies at a very large scale, and there's no really beautiful slide for me to show you about that because it's a lot of just data work, but that's kind of our most advanced case. So what's the business takeaway? The fact is it's actually the same as the technical takeaway, which is we need domain expertise. It's really interesting to just pull stats from the data, to run basic analyses on the information, to find kind of anomalous readings using just math, which I like to do on my own. But the problem is that each individual company has a specific need. And while we know we can't answer each specific need, we know we can answer the kind of superclass of question. And that means we work very, very closely with our customers, with the governments we work with our data partners, and then we connect them directly to our engineering department. So there's a lot of customer and government to engineer relation that you don't see a lot of other places. And then we construct these front-end and back-end systems to handle those cases. The future for Panjiva, currently, what we see, what's next, we're always trying to acquire more data. Obviously, the more governments that report, the more visibility that we have into fraud transactions or value transactions, things of that nature. We're also looking for higher quality data, and going back to what the gentleman from Dun & Bradstreet mentioned yesterday in his presentation was not just gathering higher quality data, but understanding fundamentally what quality means in the sense of trade data. Is it more fields? Is it more information? Is it better spelling? All of that's under investigation. For creating more tools for a wider range of clients, but still keeping the platform really easy to use and making it as open as possible for transparency's sake. And then finally, for custom services, both creating applications to help large businesses gain value, or in the sense of customs services, helping countries manage their ports more effectively and in a more automated fashion. So with that, I will open it up for questions, and if you guys don't have any questions now, you can feel free to contact us. Our information is up on the screen.